Hello everyone, reporting today for Fun Robotics Network. I'm Abhas, and with me here is Team 21311, Lion Robotics Gold from Clear Lake, Iowa. Lion Robotics Gold is currently 41-0 this season, an absolutely unbelievable statistic. They're ranked 6th by OPR, 7th in auto, 9th in teleop, just absolutely unbelievable all around. I can't wait to jump into this team on Behind the Bot. Okay guys, so, as I said, 41-0, that's just a crazy statistic. I'm honestly not sure if we've seen that from a team before. I think this has to mean that you guys have been extremely consistent the entire season. So why don't we touch briefly on what do you think has carried through really well from early season into now, and then what were some changes, like big changes you made between early season and now, kind of looking at both of those fronts.
So a large focus on our early season robot was to just keep it simple, reliable, and have lots of fail-safes built in. That way, no matter what happens during a match, we can, just make sure we have the best way to complete the task. And if something might not work on one portion of the robot, we can still score in other ways, shapes, and forms.
That makes a ton of sense. Yeah, and now kind of like looking at kind of the biggest changes you've made, what do you think are like one or two of those?
We pivoted from early season, we were using a bucket design to place into the bucket. But the problem with that was it didn't have a lot of overfill. And so we couldn't fit very many samples in the bucket. So we pivoted this double pivot design, which allows us to have a much better overfill by placing in many different ways into the bucket.
Cool. Yeah, and I think one of the most impressive things with you guys as a team is that 8-sample autonomous that you've been talking about, right? So let's use that kind of as the main subject for guiding our discussion today. And so starting with just the preload and the samples on the field, with your deposit, how can you do those so quickly in order to have time for everything else?
So yeah, our autonomous starts obviously with our intake, and we do is the start of autonomous, we grab our alliance partners preload, and then we transition to grabbing all the other ones at the same time. And so we try to do everything pretty much at once. So we're always like, we have the extender shoot out at the same time as the lift goes up, and we have everything moving at like the same time, so we can get ready to grab the next one while it's placing the previous one. And now we can have everything as quickly as possible.
Yeah, and taking a closer look at your intake, why don't you walk me through it real quickly? I think I see some super speed servos there. Is it really just simplicity is key there, or are there any critical elements that you think really make it better?
This was pretty similar to like the first design we stumbled upon, and what we've really changed throughout the season is actually just the ramp on the bottom has progressively gotten, more forward throughout the season. But it is just simply stack Gecko wheels on Go Build the super speed servos. It's light, simple, strong, and very, very reliable. And so we have a color sensor there that helps with some other autonomous recognition. But yeah.
Got it, yeah. And as far as like testing spacing and stuff like that goes, was that something you guys played with a lot early season, or did you just like find the right distance and you just kept that up until now?
We tested a little bit. We found that like if you push them too close together, it does work effectively for grabbing, but if you just have it slightly less large than the width of the sample, then it's going to grab very effectively from most angles.
Got it, yeah. And talking about that transfer sequence, can you walk me through what that looks like? If there's any specific automations or timings that you really have to nail down to make it super consistent?
Yeah, so what we do with our transfer sequence, if I grab, pull back in, comes in, and then we originally had it automated, the transfer. We found that sometimes if our intake didn't grab it perfectly, it would grab around the sample and it wouldn't grab it properly. So we actually just have that manually. That way during teleop, I can just spin the intake again to get it correct before I transfer.
Got it, yeah, so that's a neat little trick. I think teams every year transfer something they struggle with, and doing that intaking right before they go again could definitely level things up. Now, focusing a little more on the software side of auto, I think I saw that limelight camera in the corner while you were showing the intake. Walk me through how you guys use that and some of the challenges you faced.
So with our limelight camera, we trained a AI model with a data set, I believe around 8,000 images, sorry. And so we utilize the limelight camera to see the position of the samples in the submersible during autonomous, so that our intake can automatically align to the samples and grab them during our 8-sample autonomous.
Cool, and I think there's a couple different ways to go about this, right? I think the two most obvious ones are, okay, you see where the sample is and you calculate its location in like kind of the robot or global coordinates, like the same thing you would use for your pathing, and then you say like, okay, how do I get my intake to that position. The other way is like constantly saying like, okay, the sample is here, my intake is here, how much more do I have to move, like just a little bit each time? Which one of those methods do you use, or is it just something completely different for that control?
We use the latter method.
Okay. Okay. So it's just, yeah, so you're never actually calculating where exactly the sample is, just more like how quick, like how much you need to move towards it every frame. Is that correct?
We calculate where it is in reference to the robot.
Okay. Okay, got it. And as far as like consistency goes, what do you think are like the biggest things you've done to really improve your intake and consistency on that front?
So with our intake, that goes into a lot of our intake ramp design changes to make it so even if the intake grabs like slightly weird angle, it by intaking inwards will center it enough to get it to grab even if it doesn't grab perfectly.
Okay, and so like let's say the situation you have on screen here, how do you then transfer those types of samples that are kind of not placed perfectly for your transfer?
The intake, it usually will spin in and get it centered pretty much everything.
Okay, awesome. Yeah, and I think something I've seen teams that don't have like those top-down claw designs, but rather active intakes as you guys have, is they struggle with getting samples that are all clumped together. So do you have some specific algorithm for picking which samples you go to, or are you able to deal with clumps in a different manner?
Yes, so the model that we have trained is very good at picking out individual samples in a clump. And then as well, we run it through basically a simple scoring algorithm to calculate which is the best available sample. And that takes into account things such as, are there any other samples in front of it that are right next to it? How close is it to the robot currently? And of course, color. So it likes to pick the ones that has the most open space available in front of it because our intake needs space to drop down.
Yeah, absolutely. That's super neat. So now going on to your deposit, we've talked about the intake a ton. Let's talk about the deposit. You mentioned the double pivot. So what was the driving decision behind that double pivoting design?
So with our initial design with the bucket, it just didn't have much versatility, and we also had to have a completely separate mechanism to grab and place specimens. So the double pivot allows us to have multiple different positions to grab specimens and place specimens while also giving us different positions for our high bucket so we can place in a quick fill position. And so this just has, it's faster to get to and it drops closer to the bucket, which means we don't have to spend as long driving. And then we have an overfill position that also allows us to overfill easier.
And I would also like to highlight another unique component of a robot as well, if I power it up, is that when we grab and it flips over, if I actually did the transfer,
Yes.
it flips the sample to be placed horizontally instead of vertically. And we do that by not closing the claw super tight. We leave it a little bit open. The way our claw designs is as it flips over, it actually flips the sample to be horizontal. And by placing the samples in the bucket at this angle instead of vertical, we can get more overfill. But then we're also able to later on tighten, like at the end of the match, we can tighten the claw up more, and that'll keep it vertical as it flips over, which allows a couple extra into the bucket if necessary.
Wow, yeah, that's super cool. And I think that's something we'll see teams, coming into the World Championship, that's something they're totally going to have to consider way more. So it's awesome to see how ahead of the game you guys are there. Now, talking about that double pivot just a little bit more, it's super, super fast for actuation. So as far as weight savings goes, are those like carbon fiber arms you have there? I noticed like it's just like single cantilevered arms. What's going on there?
So initially we just used a lot of Go Build the channel on it. And so we realized that we could reduce the weight exponentially if we just used more carbon fiber to produce the parts, as well as we built in servo blocks, because the Go Build the servo blocks are one of the heaviest parts of our original double pivot. And so we built in servo blocks and bearings to keep it rigid and not take out the servo if we have something go wrong. Just kind of risk management there, as well as the carbon fiber keeps it way more lightweight, allowing us to pivot from one position to another a lot faster and making our lift speed also, it can get from point A to point B a lot faster.
Cool, yeah, and I see the one more servo right there at the end. Is that for some sort of yaw ability, or what are you using that servo right at the end for?
So we primarily use that during our 6 specimen autonomous. So we can grab specimens off the wall at an angle and then place specimens at an angle, so that during our autonomous, we can place and grab in a straight line, basically. We don't have to turn while doing our 6 specimen autonomous. It can just go back and forth, back and forth.
That is really neat. Awesome. Yeah. So now looking forward, looking towards endgame as far as hang goes. So at least you guys have that level 2 hang. Is level 3 something you just decided was not worth considering, or you didn't want to go for it at all?
So we definitely looked at level 3 hang and we did experiment with it, but what we found was that the offset you have to have for, the amount of weight you have to add or the amount of design changes you have to make to your robot to accommodate for level 3 hang hurts our other factors of our game to the point where the point offset isn't worth it from getting a level 3 hang. And when our level 2 hang only takes, half a second to 1 second to just get there, line up and hang, it's well worth it to just have that level 2 hang in your back pocket, keep it reliable, keep the robot simpler without strings or other things that would break.
I mean, we did try level 3 hang, but we didn't quite get it working. So maybe if we make Worlds, we'll put that in there.
Yeah, absolutely. And just one last thing, touching on your actuator. So obviously 4 motors for the drivetrain, that's fine. Is it 2 motor intake, 2 motor lift for both the actuations, or something else?
So we have 1 motor on our horizontal extension, and then part of our, one big factor of our speed is that we have 3 separate motors running our lift.
Okay,
so in here, we've got 3 pulleys all separately running to power our lift. And so that is a very large contributor to how fast we're able to place samples.
Because as far as ratios go, are we looking at 435 RPM, 1120s? What are those motors?
Those are all 1120.
Okay.
Or
Very
11.
cool. Yeah, and with current draw, has that been an issue for you guys? Have you measured the current draw and seen that you're right at that peak power output? What's that like?
We are right at that peak power output. Yes.
Okay. Cool.
We are right there at that limit.
There's a lot of power management that goes into our autonomouses.
Okay, very neat. And so was that kind of balancing your spool diameters with the weight of your subsystem, or intentionally lightening your subsystem? How did you get that balanced?
Yeah, so we have a little bit smaller spools than most people would use for that reason. So we're using 24 millimeter spools. Usually people run a little bit bigger than that, but we found that to be better for our lift as well. With our 3 motors, we get pretty much instant acceleration, so it's about the same speed as most other people's lifts running the same speed, but with larger spools.
Yeah, and you can still hang off it, so all good things. So, all right. Well, Lion Robotics Gold, thank you guys so much. I've been waiting to do this interview the whole season. You had a fantastic competition last weekend. Wanted to grab it right before your state championship. So, best of luck to you there. I'm sure you guys will do well. Again, thank you so much. Reporting for Fun Robotics Network, I'm Abhas, and this is Team 21311, Lion Robotics Gold. Thank you.